All right, here we are, 2020 again, and we're doing 4.2, combining functions algebraically. So yesterday we went and we looked at what happened when we would combine functions graphically. We noticed that if you're adding, then you're adding the y values. If you're subtracting them, you're subtracting the y values. So now we're just going to do that all algebraically. So basically, algebraically, we can combine the equations to produce a new equation. The new equation is going to automatically give you the same value as the sum of the two original equations. So for example, and yeah, I should probably say this process works for all other three operations. So let's do an example. If we have f of x being equal to 3x minus 8 and g of x equaling negative 2x plus 5, we can go and we can graph them and we can go find f plus g of x. If we look at just the individual values for the y values, so if we go plug in and find f of 1, plugging 1 in for x, you're going to get negative 5. And if you plug 1 in for x into g of x, you get negative 2 plus 5, so you get 3. Let's go algebraically find what this is, and then we're going to look at, well, what's the value when we go to that one. So algebraically, if we add up these two functions, let's do that over here. So if I take 3x, subtract 8, and then I add g of x, which is negative 2x plus 5. So if we add them together, I'm going to get x, and negative 8 plus 5 gives me negative 3. So this is going to be f plus g of x. So if I go plug in 1 into here, I'm going to get negative 2. Now, if I go negative 5 plus 3, I get negative 2. So that seems to work. Yeah, down here, we should have written our function down here. We were calling it h of x, but this is f plus g of x. When we go plug it in, like I said, we get negative 2, which works for that. So it's clear that algebraically, if we're adding them, we're just going to add them together. Let's look at another example, a little bit more complicated. So here we got the square root of x, and g of x is x minus 3. So let's go find the domain and range of each one individually. Okay, so for a, the domain and range. So the domain for this one is going to be x greater than or equal to 0. And the range, well, we know what this one looks like. It's y greater than or equal to 0. For this one, x is an element of the reals. That's for the domain. And for the range, well, it's just a linear function. So we know that it's going to be y element of the reals. So that's A. It says, given d of x is f of x minus g of x, write an explicit equation. So they're asking us to find the combined function. So I'm going to do B over here, I suppose. So we're going to go find, we're calling it d of x. So d of x is equal to f of x minus g of x. Now you want to be careful and make sure that you have them in the right order. So f of x is the square root of x. So I'm going to write square root of x, subtract, and I'm going to want to use brackets x minus 3. Now this is going to be an ugly looking one. If you distribute the negative into the brackets, you get square root of x minus x plus 3. So there's the explicit equation, and you don't have to do anything else. Determine its domain and range. Well, that's going to be a little bit trickier, but we have a square root function, and then we're also subtracting x. The original restrictions on here are still going to apply. So when I'm looking for the domain of this, I basically can go back and look at the most restricted function. That's what's going to end up happening. So this one has no restrictions. This one has a restriction. When we look at this practically, I still can see that, well, x needs to be greater than or equal to 0 because of the square root. Okay, it doesn't matter that I can plug in whatever I like here. Over here, I can't. So that's going to be the domain restriction. In general, they're not going to get us to find the range very often on the exam. It almost never happens. It's too tricky. Without graphing this, it's going to be too hard to figure out the range. So we're not actually going to do that part. They're also asking us in part C to do the explicit equation for f of x times g of x. So let's go ahead and do that. I'm just going to get this out of the way. And we can do that down here. So for f of x times g of x, well, that's going to be just multiplying them together. So one of them is the square root of x, The other one is x minus 3. You can leave it like this potentially. You could distribute the square root of x into the brackets, so I'm just going to go ahead and do that. So I would have x times the square root of x, and then minus 3 square root x. Either answer would be fine. This one might be a bit better. Again, there's no way that we're going to find the range, but we can talk about the domain. Okay, and because of the square root, it's going to have to be greater than or equal to 0. Can't plug in anything lower than 0. So once again, I'm going to point out that when we find explicit equations for things, they're going to take on the domain restrictions of the most restricted function. Okay, that's always going to be the case. Now I got a couple questions down here. I can put this over here now. What are we doing here? Finding a couple values to verify that the combined functions do produce the correct value. Sure, let's go and do that. So f of 4, well, f was the square root function, so that's going to be the square root of 4, so that's going to be 2. So there's f of 4. What else have we got? We got to figure out g of 4. Well, g of 4, that was the x minus 3 function, so x minus 3 and g of 4 looks like it's 1. D of 4. So let's see. D, that was part B, and that was f of x minus g of x. So I would be curious to compare that after to f of x minus g of x, okay? And at the value 4. So let's go find this one first. Now, I already forgot what our function was. We had, right, square root of x minus x plus 3. So it would be square root of 4 minus x minus 3. I feel like there was a plus. Plus 3. There. So this is going to be 2, subtract 4 plus 3. So we get negative 2 plus 3, so we get 1. So d of 4 is 1. I'm not liking that really thick line there. Now let's see. F of 4 was 2, subtract g of 4, which was 1, which still gives us 1. So we can see that we get the same value. That's good news. That means we did something right. As far as p of 4 goes, now that was that ugly looking function right here. So let's plug it in right now. That's 4 times the square root of 4, subtract 3, square root of 4 again. So this is going to be 2 times 4, which is 8. Subtract 3 times 2, which is 6. So it looks like we're going to get 2. Now we can go compare it to, what was p of x? P of x was multiplying f of x and g of x together. So we can do that. We can go f of 4 times g at 4. So f at 4 was 2, and g at 4 was 1. So you can see we still get 2. So we definitely did something right. That's the end of that question. So lots of stuff getting covered in there. I don't know if we need to do this one. This might be trickier than the exam. I always like to have more questions than I need. I think we can leave this one alone. They don't generally mess around with the absolute values much when we're combining functions. Let's see. This division one might be interesting. That's going to be a similar one. Yeah, let's maybe take a quick look at this one here. Okay, so f of x is the square root of x. G of x is x minus 3 squared, so it's a parabola. So as far as domain and range go, so the domain of this one we are already very familiar is x element of the reals, but x is going to be greater than or equal to 0, and range is y greater than or equal to 0. Now this is a parabola, right? That's a parabola that has its vertex shifted 3 units over this way. So this is going to be the point 3, 0, and it'll just be opening up like that. So as far as domain goes for parabolas, it's always x element of the reals. The range, you need to think about, your actual parabola. Now this is opening up, and I know that's my vertex, so it's going to be y greater than or equal to 0, y element of the reals. Now, let's go and find, this looks like a q. Q of x is f of x divided by g of x. Sure, let's do it. So q of x is f of x, which is the square root of x, over g of x which was x minus 3 squared. Now, that's going to be ugly. We're probably not ever going to graph, like you'd never graph something like that, but they could ask you for the explicit equation, there it is, and then find the domain and range.
Jai Hao Zhang, please go to room 44.
All right, the domain and range. Well, we know from this kind of function that, well, we're going to have some restrictions down here, right? We can't plug in x equal 3. So we're going to say, let's see, x cannot equal 3. Actually, that's going to be a vertical asymptote, x equal 3. So that's interesting. We also can't plug in anything that's less than 0. Okay, so you're going to have to say x is greater than or equal to 0, comma, x element of the reals, but you also got to stipulate you can't plug in 3, so then you would say x does not equal 3. So let's take a look. Did we take on the most restricted domain? This domain had no restrictions on the original function, but this one had this domain restriction. Okay, so we always take on the most restricted domain, and then on top of that, you got to look at the function you get and see if there's any other restrictions. Okay, so most restricted domain, and we couldn't plug in 3. So you'll see that in the domain. They would never ask for the range for this question. I grabbed this from a textbook, so it's harder. They would never ask for that, so we're not going to do that. And we're not going to worry about the graph. We're not going to do any of that. I just threw it in there for your own information. So let's see if there's anything else we need to do. We're not going to do that one. It's very similar. Sometimes you get a question about this. So you're now given the combined function, and your job is to determine the original function. So say that we have h of x, and it's equal to this. Write explicit equations for 3 functions, f of x, g of x, and it's like an n of x, so that you get h of x. So you'd have to come up with something that works. 3 different functions, and you can't do stuff like just say, oh, this one is 0 and this one is 0 and f of x is that. You're not allowed to do stuff like that. But you could split it up. So you could say something like, oh, how about f of x is x squared and g of x is, the negative 2x, and, n of x is 3. Now, if you were to add those all up, you would get this. So that's probably the easiest way to do it. Write explicit equations for 2 functions, f of x and g of x, so that you get h of x. So you just need to make sure that when you subtract them, you're going to get this. So what I recommend you do is say something like, start with f of x. Now let's get creative. Like I need x squared, so I'm going to make this 2x squared, and I'm just going to say, plus 3x, and that's it. Okay? Now, when I come up with my g of x, I need to remember that it's going to be subtracting, so the sign's going to flip. Okay? So if I make it x squared, when I go 2x squared minus x squared, then I get my x squared term. I need to get a negative 2x. So I better think of here really carefully. I need this to be 5x, I think. Because when I go negative 5x, plus 3x, I get negative 2x. And then I need to have this plus 3. So I might just say, okay, well, it needs to be negative 3, so that we go negative 3, you get plus 3. Okay? So that would work. Sometimes you get questions like that. Not all the time, sometimes. We don't need to worry about these. We're not going to worry about this one. I know they're a bit trickier, but it's usually trickier than the exam. Same thing with this one. The one with the division, that's pretty tricky, but maybe we can take a look at it. So given this one, write explicit equations for 2 functions, f of x and g of x, so that when you multiply them together, you would get that. The only way I could think of doing that one is factoring this. So if you factor this, then you would have 2 functions that could work. So 2 numbers that multiply to negative 8, but add to negative 2 would be negative 4 and positive 2. So if I just said, all right, g of x is x plus 2, and f of x is x minus 4, when I multiply them together, you get that. Now that's a tricky one. That's probably the only way I can think of doing it. I'm sure there's other ways, but that's the only way I can think of. This one's even harder. So given that q of x is x minus 4, write explicit equations for the two functions f of x and g of x so that you, when you divide them, you get x minus 4. Now I think I have a little note. It says q of x has no restrictions on its domain or range, so the functions f of x and g of x, you have to choose so that you don't get any restrictions. I might have to actually check my notes on that one. I can't quite remember off the top of my head how I dealt with that. Let's see here. Oh, that's a mess. Maybe we won't worry about this right now, and I'll do that after, because I don't want to stand here for 1 minute while I figure it out. So yeah, we'll end the video there. To be honest, I've never seen a question like that on the exam. It'd be a nice to know kind of thing. So we'll end the video there. You guys can do the exercises, and we'll do a couple more questions together off video. Okay, have a good one. Bye bye.